Hello friends, today let's solve another question from electrical circuits and network. In this question, this is a statement based question. Statement 1 states two ideal current sources with current I1 and I2 cannot be connected in series. Statement 2 superposition theorem cannot be applied to current sources when one terminal of each of these sources is connected to a common node. And we can see options like statement both statements are correct, and the statement 2 is the correct explanation of the statement 1, and both are correct and statement 2 is not the correct explanation, and first statement is true and the other is false, first is false and other is true. These are the options. So let's go through the first statement. Two ideal current sources with currents I1 and I2 cannot be connected in series. Let's see how it is. So now I am connecting current sources I1 and I2 in series. So what happens here is this is a series connection. When it comes in case of series connection, the current flowing through this series connection should be same. Here I1 and I2 are different current values. So we want to say the current through this series circuit either as I1 or I2. Since both are I1 is not equal to I2, we cannot say which current is flowing through this circuit. We cannot say whether it is I1 or I2. So here also KCL is violated here. Consider a junction between I1 and I2. The current entering at that junction is not equal to current leaving at that junction. That is, I1 is not equal to I2. So the statement 1 is the correct statement. It is true because the statement 1 itself says that two current sources with currents I1 and I2 cannot be connected in series. They are telling the truth that it cannot be connected in series. Let's see the statement 2. Superposition theorem cannot be applied to current sources when one terminal of each of these sources is connected to a common node. Let's see. In case of superposition theorem, we know that while applying a superposition theorem, we excite only one source at a time by removing all other independent sources. That is by short circuiting the voltage sources and open circuiting the current sources. When two current sources are connected in series, while applying the superposition theorem, what happens is when one terminal of each is connected to a common node, then what happens is while opening one source, this will make the other source also open circuited. Okay. In superposition itself says that at a time we use only one source for calculation, and at last we will make the summation of all the individual values together and we get the resultant. That is how we do superposition. So while doing the superposition theorem, at first let's open the I1 and I2 is again there. But even though I2 is there, the total circuit is open. So the application of superposition theorem is not valid. In another case also, when only I2 is connected and I1 is open, there also the circuit is again open circuited. The superposition theorem is not valid there. So the statement 2 is also correct, that it states that superposition theorem cannot be applied to a current sources when one terminal of each of these sources is connected to a common node. That means they are connected when they are connected in series. Again, there also we cannot apply superposition theorem. Statement 2 is also correct. But the problem is statement 2 is not the correct explanation of statement 1. Okay. So answer will be option B. Hope you understood this question. If you have any doubt, please ask in the comment section. Thank you. We will meet with another question in next video. Thank you. Have a nice day.